Okay, let's solve this linear system by substitution. We've got two equations. We've labeled them equation 1 and equation 2. When we're solving by substitution, what we want to do is get one variable by itself. We could either get x's by itself or y by itself in any one of the equations, but looking at equation 2, it's probably the easiest one to get x by itself. Let's start with equation 2 and see what I mean. X plus 3y equals 31. All I have to do to get x by itself is move this 3y to the other side. That's accomplished by subtracting 3y on both sides. When I do that, I get x equals 31 minus 3y. We'll call that equation 2a. As in, this new equation comes from our equation 2, but is slightly different, in fact rearranged so that x is by itself. And now, the substitution step. We'll sub in equation 2a into equation 1. So let's start with equation 1. 3x minus 2y equals negative 39. But where there used to be an x, we'll replace the x with the value we got from 2a, or the expression I should say. That is, what used to be an x in equation 1 is now replaced with what we found x to be from equation 2a. That's what we mean by substitution. Sub one equation that's been rearranged to find the variable into the equation of the other. This is perfect because now we're left with an equation with just one variable, y. And we're going to solve, that is, isolate, for y. First thing we'll do is rainbow 3 times 31. We get 93. And then 3 times negative 3y, we get negative 9y. The minus 2y is still there, and it still equals negative 39. Now we combine like terms. Negative 9y, negative 2y is negative 11y, equals negative 39. Let's subtract 93 from both sides, and we can check it on our calculator if we need to. Negative 39 minus 93, that gives negative 132. The only thing left to do to get y by itself is divide by the coefficient of y, in this case negative 11. When we do that, we're left with y equals 12. Now that we have y by itself, we can find x. So let's substitute y equals 12 into any one of our original equations. Probably the second equation will go a bit faster, but you could have used equation 1. X plus 3 times y is 31, that's what equation 2 is, but we replace the y with 12. When we do that, we're left with x plus 36 equals 31, and now it's a simple case of subtracting 36 from both sides to determine that x is indeed equal to negative 5. Therefore, we need a concluding sentence. We found the point of intersection, that is the place where these two lines meet, and they meet at the location negative 5 for x and positive 12 for y. We can check our work, if we'd like, by doing left side, right side on both equations. Let's call this equation 1's left side, right side, and go back to the original equations and sub in the values we had for x and y. So I'll put a little line here to keep it separate. 3 times x, that's 3 times negative 5, plus 2 times 12. The question is, does it equal negative 39? So 3 times negative 5 is negative 15, plus 2 times 12, that's 24. Oh, and look, we found a mistake. It's not plus 2 times 12. Look at the original equation. It's minus 2 times 12. Gotta be careful with those minus signs. But that's one of the reasons we check, is to make sure we have the right answer. I might have made a mistake elsewhere in the question. So, let's check again. 3 times minus 5 minus 2 times 12 is negative 15 minus 24. We get negative 39. Checks out. Let's check left side, right side on equation 2. Well, the left side of equation 2, going back to here, is x, which we found to be negative 5, plus 3 times y, but we found y was 12. And so the question is, does that equal 31? Well, negative 5 plus 3 times 12 is the same as negative 5 plus 36, which is indeed 31. Since both equations check out, that is, when we substitute in, we get left side equals right side in equation 1, and left side equals right side in equation 2, we know that we have the right answer.